Okay, so I'm gonna be doing the FRQ1. So for part A, it says that I have to draw the forces. So there's FG and there's FN, and then there's also FK acting against. For part B, I'm gonna start with MEI equals MEF. And for MEI, there's a height, so there's PE. And it's starting from rest, so there's no KE. And for MEF, there's KE linear and KE rod. And for PE, it's MGH naught, because that's the height in the beginning. And for KE linear, it's 1/2 MVF squared plus 1/2 I omega squared. I'm gonna plug in the M and R that's given for the moment of inertia. So M naught and R naught, and this is squared. And I'm gonna convert this to V over R squared. And this is gonna cancel, and this square root in, so MGH naught equals 1/2 MV squared, VF squared, plus 1/2 M naught and V squared. And the M are on both sides, so I'm just gonna cancel that out. So this equals to GH naught equals 1/2 VF squared plus 1/2 V squared. And this is VF, so I'm gonna add these, and which equals to GH naught equals 1 VF squared. And 1 move over, it's just gonna be GH naught equals VF squared. And I'm gonna square root both sides, so VF equals radical GH naught, and that's equals to VCM. For part C, I'm gonna start with KE total equals KE linear, because it's sliding down, plus KE rod, because it's also rotating. And this equals to 1/2 MVF squared plus 1/2 I omega squared. And I'm just gonna rewrite, because I need to plug in M naught, which is given, and R naught, which is also given, and I have to square this R. And for omega, I'm gonna change it to V over R, and I'm gonna square it. And I'm gonna cancel out this R, and it's gonna give me 1/2 MVF squared plus 1/2 M naught V squared. And this is VF. And this is VM naught. So I'm just gonna add them, which give me 1 M naught VF squared for KE total. And it's asking for KE rod over KE total. So KE rod is 1/2, and KE total is just 1. So that would give me 1/2 for the ratio. For part D, I disagree because ACM is equations is G sine theta over 1 plus C, and G is constant, and so is C, which makes it depends on theta. Theta is changing because it is a curved ram. For part E, I also disagree because the equation for VCM is radical GH naught, which we found in part B. And G is constant, and since H naught is doubled, you would think that it doubles, but there's a radical causes us to not change. For part F, I'm gonna start with delta y equals 1/2 gt squared plus vi y t, and since vi equals 0, I'm just gonna cancel this viy out. So, and this equals to h capital naught. So h naught equals 1/2 gt squared, and I'm just gonna do algebra to isolate for t. So h naught times 2 over, so 2h naught equals gt squared, and I'm gonna divide g over, so t squared equals 2h naught over g, and I'm gonna square root both sides, so t equals square root of 2h naught over g radical. For part G, I'm gonna start with delta x equals 1/2 at squared plus vixt, and I'm gonna cross out a because vx is constant, so delta x equals vix t, and for vix, I'm gonna plug in, for delta x, I'm gonna plug in d because that's the distance, and for vix, I'm gonna replace it with VCM, which I found in part B. So radical GH naught times by t, which I found in part F, which is radical 2h naught capital H over G. And through this, I'm going to cancel out G, and the distance will equals to radical 2 H naught and capital H naught. For part H, I disagree, because when it leaves the edge of the table, the force acting on it is gravity, and it goes through the center of mass. So the net torque equals to 0, which makes omega equals to 0. Because net torque times delta T equals I omega. For part I, the solid disk and the hoop produces the same amount of energy. And time, because they have the same height. But the KE rotational is different, because moment of inertia for the solid disk is equals to 1/2 mr squared, and the moment of inertia for the hoop equals to 1 mr squared. So the moment of inertia of the solid disk is smaller, which causes the KE rod of the solid disk to be smaller too. So the KE linear for the solid disk has to be bigger to make up for it. So the KE linear will causes the solid disk to travel farther away.